Yuri, everybody knows you have to invert and multiply fractions to divide them.
Invert? I think my math teacher said flip-flop the numbers.
Yeah. Doesn't matter what you call it, just divide. Your brainwaves shouldn't surprise me, Yuri. And yet...
Well, hello. Uranium and ruthenium. This is a rather unusual way to complete your math homework.
It's not homework. Mom and Dad went out for the night, and they left us a mac and cheese recipe. But we only have a 1/4 measuring cup and...
Why on earth do you have an ancient cookbook that uses the archaic imperial system of measurement?
What's Earth?
And aren't you Imperial, Xenon? Like part of the nobility class or something?
Earth is a planet in the Milky Way galaxy, and a few primitive Earth beings measure things in an outdated and vexing system of measurement that uses inches, cups, ounces, and other convoluted units. And Yuri, I'm a noble gas, but... here we go.
Metric, macaroni, and cheese.
Electric macaroni?
No, Yuri, not electric. Metric. It's a very simple system that measures everything in multiples of 10. Now, do you think you can do these math problems?
Ooh, this is an easy one. Anything multiplied by 1,000, you just add 3 zeros and move the decimal 3 times to the right.
Mine is harder, but I'm smarter than my brother, so we just move the decimal to the left 1 time for each 0 in 100.
Excellent. So, we divide by 1,000.
I've got this.
Marvelous, Yuri. Maybe you can be less of a bully to your brother now.
You mean I should get a new hobby?
Yeah, Ruth, quit being so mean.
Well, if you weren't so dumb.
Ruth, stop.
I think she's hangry.
Yeah, I blame my low blood sugar. Let's get cooking.
Ruth, you're just rude sometimes. Consider counseling.
I'm perfectly normal. You're the weirdo. This weirdo recipe is all in measurements labeled ML, and what the heck is that?
Let me demonstrate. I just came from my lab's sterilization plant, so all my measuring equipment is clean enough to eat from. ML stands for milliliter. Milli is a prefix that means 1/1000th. It's equal to 1 cubic centimeter.
Is that like a centipede?
Centi is a prefix meaning 1/100th. 1 centimeter is 1/100th of a meter, a bit wider than a pencil and a bit smaller than a whiteboard marker. A cubic centimeter is roughly the volume of a pencil tip eraser once it's removed from its socket.
My stomach doesn't care.
Understood, Ruth. This is what you need. Let's use it to measure our macaroni.
Your cell phone recipe says we need 500 pencil erasers of macaroni.
500 milliliters, yes.
Your graduated cylinder says 1 liter on the top. So, 500 milliliters would be half a liter?
Why, yes, Ruth, brilliant. 1,000 milliliters equals 1 liter.
And it says we need 250 milliliters milk, 300 Gs of shredded cheese, and 50 G of butter. I can figure out the milk, but what's up with the G's of cheese and butter?
G stands for gram.
Spam?
No, Yuri. Have you had your hearing checked lately? 1 gram is roughly the mass of a paperclip. We can weigh those ingredients on this scale.
We're adding paper clips to our mac and cheese?
Oh, forget the hearing test. My brother needs a brain test. And what are you doing, Yuri?
Aren't we supposed to boil the water? Xenon, what temperature does water boil at?
That's a Celsius thermometer, and Yuri, water boils at 100 degrees Celsius. But, of course, we add 273 to convert to Kelvin in my chemistry lab, so in there, I like to say that water boils at 373 K.
I thought water boiled at 200-something degrees.
You're probably thinking of Fahrenheit. The metric system for measuring temperature is much easier to remember. Water boils at 100 degrees Celsius and freezes at 0 degrees.
Yuri, help us out here.
I am helping. I'm watching the thermometer.
You don't need to watch the thermometer. When the bubbles start, that's boiling and we can throw in our macaroni.
Ooh, I see a bubble.
The metric system is brilliant and easy to use, which is why scientists use it in their labs. 1 cubic centimeter equals 1 milliliter. The mass of 1 milliliter of water is 1 gram, and all units can be simply divided or multiplied in batches of 10, 100, or 1,000. We can picture this like stairs that lead up to the next floor or down to the basement.
Oops, I guess I grated too much.
Did you weigh the ball first?
I
You need to weigh the ball, then add the cheese, and subtract the weight of the ball.
knew that.
I believe it's well past time for the two of you to learn the metric system as well as SI units.
What are SA units?
SI is a French term that stands for Système International.
Très bien. Beautiful.
With apologies to French speakers for how I butchered that pronunciation.
Oh, I love it. The words melt in the mouth.
It's an internationally recognized system of measuring units.
Like what you said with Celsius converting to the Kelvin religion?
Kelvin is how we measure temperature in science. It's not a religion.
Where are the erasers on your list?
Milliliters.
That's correct, Ruth, but the SI unit for volume is actually a cubic meter, a large amount of liquid we wouldn't typically use in a chemistry lab or a kitchen. So we divide them into liters, 1/1000th of a cubic meter like that bottle you're drinking from, and into milliliters for smaller portions.
Pencil erasers.
Again, Yuri, they're a bit larger than a pencil eraser. Here's a few other SI base units. For time, second. For brightness, candela. Electric current, ampere. Amount of a substance, mole.
Oh yeah, I remember we talked about moles that day we made cookies. It's a humongous number, right?
It certainly is. 6.022 times 10 to the 23rd power. It's equal to several trillions. Pressure of gases is measured in pascals, but in my laboratory we usually measure in atmospheres. 1 atmosphere equals about 100,000 pascals. Finally, the SI unit for mass is...
Gram. Yeah, we know, Xenon. You can end your lecture now.
You're on the right track, Ruth, but we actually measure in kilograms.
Killer spams?
Kilograms. The prefix kilo means we multiply by 1,000.
So, a kilogram is 1,000 grams?
Ruth, fantastic!
And 1 gram is 1/1000th of a killer spam?
There's no spam killing anybody.
1 gram is 1/1000th of a kilogram, Yuri, so... You were correct, other than the spam part.
So, 1,000 paper clips can get together and create 1 killer spam?
Well...
Forget it. Food's ready. Let's eat.
We have a good thing going, Ruthenium.
Yeah, Zinc. We have chemistry.
Hello, Zinc and Ruthenium. In actuality, I suspect your feelings are merely physical, not chemical.
Xenon, You're interrupting.
Yes, I know, but when I hear atoms that don't know the difference between a chemical and physical reaction, I can't help myself. I have to set them straight.
Okay, but...
Xenon, what are you doing?
Look, I've read plenty of science journals, and I can't recall ever reading about a chemical reaction between zinc and ruthenium atoms. Allow me to show you what a chemical reaction really is.
Xenon, we're on a date here.
I'll make this quick. Now, as you can see, I mixed brown goo powdered drink mix with water. It's just a simple physical reaction. I dissolved my drink mix in water and created a simple solution. I can sit this on the Bunsen burner until the water evaporates, and it will merely become powdered drink mix again, as the surrounding air absorbs the water vapor.
Yeah, okay. Physical change, we get it, but...
Good! Physical changes are generally reversible, but a chemical change is not as easy to reverse.
Okay. It looks like you're writing in the sand something about methane, oxygen, carbon dioxide, and water.
You're much smarter than you look, Zinc. CH4 is methane, and when we combust it, like in this Bunsen burner...
You mean burn it.
Yes, Ruth, to combust means to burn. You're about as smart as you look. Anyhow,
Hey, Xenon, what did you mean by...
as I was saying, Ruth and zinc. We see methane in this chemical formula combined with oxygen from the air, and this error means it yields to become carbon dioxide gas plus water vapor. The atoms in each part of our chemical reaction do not disappear.
Yeah, they just rearrange themselves. I get it. It's a chemical reaction, not just a simple physical change.
Excellent, Zinc. Now, we have subscripts and coefficients in our chemical formula.
Right. The little numbers are subscripts, like the 4 in CH4. They tell us how many atoms are in each molecule.
Correct. CH4, the methane compound, has 1 carbon atom and 4 hydrogen atoms in each molecule.
And coefficients. I learned about those in math class.
That makes sense, Ruth. In chemical formulas, coefficients are the larger number to the left of each molecule or compound, and they tell us proportionally how many of each molecule we have in our formula.
So we have 2 O2, or oxygen gas molecules in this formula, and 2 water molecules, but there's no coefficient in front of methane or carbon dioxide.
Correct. When there's no coefficient, we presume there's just 1 molecule or 1 molar portion.
Molar portion? Like teeth?
No, Ruth. In chemical formulas, we can simplify down to 1 molecule at a time. But in reality, we're generally talking about moles of compounds. A mole, as you may recall from when we cooked up sugar way back when, is a very large group of atoms or molecules.
So this is a chemical formula representing a chemical change. 1 portion of CH4, methane gas, combines with 2 portions of oxygen gas to become 1 portion of carbon dioxide gas and 2 portions of water, H2O.
Excellent, Zinc.
So we have 1 portion of carbon on the left of the arrow and 1 on the right, 4 portions of hydrogen on the left, and 2 plus 2 on the right.
You're almost there, Zinc. The coefficient multiplies everything in your molecule.
Okay, I think I get it. We have 2 times 2, or 4 portions of oxygen total on the left, and 2 times 2, or 4 portions of hydrogen on the right. And I guess 2 times 1 oxygen on the right in our water?
Yes, plus...
Oh, 2 times 2, or 4 oxygen on the left, plus the 2 in CO2, and 2 more in our water molecule.
Bingo, Zinc! It balances. Equal numbers on the left and the right. And since it's much easier to combine methane and oxygen and get carbon dioxide and water than it is to reverse the equation, we call this a chemical reaction.
If I break the stick, that's a chemical reaction?
No. It's physical. The molecules in your stick haven't rearranged themselves into anything new.
But if I burn it, chemical reaction?
Yes, Zinc, I think you're getting it. We can't unburn the stick, can we? In this chemical reaction, the stick molecules, along with the oxygen that helps them burn,
They transform, right? They turn to ash, carbon dioxide, and water vapor.
brilliant! Unlike physical changes, chemical reactions typically result in a change of temperature, sparks, bubbles, or some other indication of molecular transformation.
Like barium that sparks green in fireworks.
Or iron that crumbles to rust.
A chemical reaction can't be reversed. Like love that we have between us.
Oh, Xenon, isn't he dreamy?
Ruth, if you're saying he's handsome, you realize that's merely physical.
No, Xenon. It's love. It's chemistry.
Like food in my belly, digesting to goo.
Like chemistry brewing between me and you.
Like cyanide used to mine ores for extraction. It runs in our blood. A chemical reaction.
Well, I'm not so sure young love is chemical and not merely physical, but I suppose it could be both.
Xenon, don't you have somewhere to be?
I can take a hint.
You don't know what you're talking about, Zinc. And you're not helping.
Hello, uranium, ruthenium, and zinc. What are you squabbling about this time?
Thanks for coming by so quickly, Xenon. I'm tired of hearing my sister and her boyfriend fight.
I wouldn't call it a fight.
Zinc thinks he's a know-it-all who can tutor us on our molar mass and volume chemistry homework.
I tried to explain to them that molar mass is the number with the decimal on each square of the periodic table, and I point out that this equals the number of grams per mole of an element, but Ruth thinks I'm wrong.
Not wrong. Just a liar. Or dumb. Or both.
Ruth, we've talked about your rudeness and name-calling.
Sorry, Zinc. I guess dishonest and ignorant would have been better word choices. Look here, Xenon. You told me way back when that the whole number is atomic number, which makes you atomic number 54, which means you have 54 protons in your belly.
54 protons in my nucleus, correct?
Yeah, I know I'm correct, 'cause I'm not ignorant like my ex-boyfriend Zinc.
Ex-boyfriend?
Uh-oh.
Ruth, can we talk about this?
Talk to the hand, Zinc. Me and Xenon are busy. Anyhow, Xenon, you told me the decimal is atomic mass units, which means if we put you on a scale, you'll weigh 131.29 AMUs.
More specifically, Ruth, it means the total mass of one xenon atom averages 131.29 AMUs.
Which means the total of your 54 protons and the average number of your neutrons equals around 131.
Yeah, I know, Zinc. I've been trying to tell you that this whole time.
But Ruth, that's not what our molar mass homework is asking for. The homework never mentions AMUs.
Yuri, molar mass is the mass of 1 mole of a substance, meaning a specific large quantity of particles, which means 1 mole of xenon atoms has a mass of 131.29 grams.
That's confusing. I don't think you and Ruth can both be correct. But don't ask me to take sides, 'cause you're my friend, Zinc, but I have to keep living with my sister no matter what.
You don't need to take sides, Yuri. Ruth and Zinc are both right.
So, Xenon, you and Zinc said molar mass is the decimal number on the periodic table. I'm uranium, and me and other uranium atoms have an average mass of about 238 grams per mole?
Correct.
I think we talked about this a long time ago, but remind me, Xenon, what's a mole in chemistry?
It's a gigantic number, Ruth. 6.022 times 10 to the 23rd power.
I wasn't asking you. I was asking Xenon.
Zinc is correct. The word mole simply stands for a fixed and very large number. You might say it doesn't mean 12, for example. Similarly, 1 mole equals 602 sextillion, which is several trillions, hence the scientific notation.
I can't even picture that. That's like all the atoms in the universe.
Not quite, Yori.
Not by a long shot, my friend. 1 mole is the number of atoms or molecules it takes to create so many grams of a particular substance. Here's an example. An empty aluminum can weighs about 14 grams. Let's say that can is pure aluminum. Aluminum is nearly 27 grams per mole, so 2 pure aluminum cans would have a mass of about 1 mole.
Wow, that's a whole lot of aluminum atoms in those cans. And that also means there are billions and trillions and gazillions of other uranium atoms just like me in the world?
Uranium, you are unique, countless, and priceless, all rolled into one.
You can quit gushing over my brother now, Xenon. I just want to know. Our homework is asking us to figure out the molar mass of molecules. So there's trillions and trillions of molecules in 1 mole of those molecules. Am I right?
Absolutely, Ruth. Let's look at another example. Let's say zinc and our friend oxygen get together to make a molecule.
Oh yeah, me and Oxy did that just the other day. We made zinc oxide.
And what would the mass of 1 mole of zinc oxide be?
My average mass is 65.4 grams per mole, and the molar mass of oxygen is 16 grams. And I guess I just add them together?
Brilliant, Zinc.
That's helpful, but not all of our homework problems are that easy.
Like, here's one tough question. What is the molar mass of carbon dioxide?
Well, carbon dioxide is made of 2 moles of oxygen for every 1 mole of carbon, so...
Ooh, I think I can do this one. The periodic table tells us carbon is 12.01 grams per mole, and oxygen is 16 grams per mole. But we have 2 of them, so... Anyone know what 16 times 2 is?
32.
Oh yeah, thanks, Zinc. 32 plus 12.01 equals 44.01 grams per mole of carbon dioxide.
Fantastic job, Yori.
This is a super tough one. It says, what is the mass of 2.5 moles of RuCl3? Wait, is RU me?
Are you me? No, I'm not you. Thank goodness.
RuCl3 is the formula for ruthenium chloride, which you can make with the chlorine triplets, Ruth. Why don't I walk you through it?
6.022 times 10 to the 23rd power of me equals 101.1 grams. Chlorine is 35.45 grams per mole, but there's 3 of them, so that means 1 mole of RuCl3 has a molar mass of 207.45 grams.
But the question asks, what is the mass of 2.5 moles of RuCl3?
I think you would just take your original answer and multiply by 2.5.
Think you're correct once again. Give it a try, Ruth.
My cell phone calculator says 518.625 grams.
Excellent job, Ruth. Do you think you and your brother are ready to finish your homework without my help?
Not yet, Xenon. There are also questions about molar volume.
Oh, that's simple. But keep in mind that molar volume only applies to gases. Just follow Avogadro's law. At standard temperature and pressure, 1 mole of any gas equals 22.4 liters.
I'm confused. I thought moles were different amounts for all substances.
Gas particles float and don't touch each other. The molecules spread out. Xenon's just saying that as gas molecules spread out, they fill a predictable volume.
Zinc, what gases are in those balloons?
The green one is oxygen in the form of O2 gas, the purple one is CO2, and the blue one is nitrogen in the form of N2 gas.
Wait. How did balloons magically get into our closet?
Oh yeah, Zink snuck them in here earlier. He was gonna surprise you.
They were gonna be a gift for you, Ruth. But then you broke up with me, so
Zink, how many liters are in each of those balloons?
they all hold 11.2 liters.
Thanks. We're not quite at standard temperature and pressure, but we're close. 11.2 liters means each balloon holds half a mole of gas. As we can see, each balloon has the same volume, but if my math is correct, we could put each balloon on a scale and see they each weigh slightly different amounts.
But they're all the same size.
Wait, gas molecules are all spread out and don't touch. So yeah, I think I get it. Different sized molecules, so their mass is different, but the same number of molecules is in each balloon.
Oh yeah, molar mass, molar volume, it's all starting to make sense. Zink and Ruth, I think we can finish our homework without you now.
No, wait, my sweet Winky Zinky Boo. Don't go. I'll miss you.
Are we good now, Ruth?
I could never stay mad at my Zinky, and I don't want you leaving with that super cute balloon bouquet.
Molar mass is elementary.
Yes, it is.
Now we see.
Check each atom on the table.
Periodic table.
We see that.
So simple.
Simple.
It's the number with the decimal.
Yep, it's fun.
Fundamental.
Molar mass for each element.
Yep, right there.
Message sent.
Bye-bye.
Wait, there's more. It's not just atoms.
Let's look at
Molecules.
Add your molar mass together.
simple maths.
Not confused.
We've established that molar mass for each element is right there in black and white on the periodic table. It's expressed in grams per mole, and you can add molar masses to learn the mass of compounds. But let's review.
Remember, if you have multiple moles, multiply the total mass of the compound, and if you have partial moles, multiply by the fraction or percentage of the mole.
Now, do we need one final review of molar volume?
Sure, why not? As long as we can keep on singing.
Molar volume's elementary.
It sure is.
Now we see.
Easy.
Gases may make things look empty.
Yes, we know.
We can see.
Molecules are spaced
There's
out
so
plenty.
Filling space.
Now we see.
Tell me this, are you still confused?
Nope. Let's weigh molecules. Uranium. For the crime of attempting to break the law of conservation of mass, I sentence you to house arrest with Xenon. Yuri, you'd be better off in jail. Silence! Contempt of court. For that outburst, Missy Ruthenium, I sentence you to serve time with your brother, listening to Xenon lecture on scientific law. But Judge Iron, Your Honor... And Xenon, the court is well aware that you're a gas sometimes used in anesthesia, and therefore the court reminds you to not allow these two to sleep during your lecture.
Understood, Your Honor.
You're dismissed.
Xenon, can I tag along?
Of course, Zink. And Yori, remind me, how did we get here?
Well, I had started a flower garden, but they weren't growing well. I thought maybe the little buds weren't warm enough, so I lit a propane heater next to them. But the propane disappeared just as a cop pulled up, and I told him the propane atoms had vanished. And he said I was a liar, that wasn't possible, and then he wrote me a ticket, and I don't know what I did wrong. I'm so confused.
Did you ever think about watering those flowers, Yuri?
I didn't realize you lived this close to the courthouse, Xenon.
It's rather convenient when my friends get into trouble. Or my students.
What kind of school do you teach at?
Oh, typical college student shenanigans. Now, you three have a seat. By coincidence, I've been prepping my Chemistry 101 students on scientific laws and balancing chemical equations.
Gosh, Xenon, that is such a lucky coincidence.
We are lucky because we're not in jail.
Propane's chemical formula is C3H8. Do any of you know what those numbers mean?
Oh, yeah. They're subscripts, right? We talked about this once. That means each molecule of propane has 3 atoms of carbon and 8 atoms of hydrogen.
Marvelous! Since propane is a gas, we add a letter G next to it in parentheses. Now, nothing can burn without the presence of oxygen.
I'll get it. Oh, hi, Oxygen. What brings you here?
Bonjour. I was passing by and heard you talking about molar. Did you need me to help you burn something?
Not at the moment, oxygen, but perhaps you can help us in a bit. Again, methane and anything else that's flammable can only burn in the presence of diatomic oxygen gas, O2.
Oui, oui. Moi and my twin brother.
Of course, and like any combustion reaction, our reactants will include a substance that contains both carbon and hydrogen. And in the end, we're left with products that include carbon dioxide gas and water vapor. Now, who can tell me, what's wrong with this chemical equation?
It isn't balanced.
We need coefficients. There is not enough of moi to properly do the job of burning propane.
Correct. Without the right coefficients, our proportions will be wrong and we won't be able to follow the law of conservation of mass.
Yeah, well, my brother's a criminal, so what do you expect?
I'm sure it was inadvertent, Yuri. You told the police officer that all the atoms in your propane tank had vanished, but that's impossible. They merely rearranged themselves. The law of conservation of mass, or matter, states that matter can neither be created nor destroyed. It only changes forms. We illustrate this every time we have a balanced chemical equation.
This one isn't balanced yet, but I think we need to look for common factors, then change the coefficients accordingly, but not the subscripts. 8 shares a common factor with 2, for example.
Brilliant! Zinc, would you like to try to balance it?
Since we have 8 atoms of hydrogen and propane on the reactant side, we'll need at least 8 on the product side, so let's add a coefficient of 4 to our H2O, because 4 times 2 equals 8. And we have 3 atoms of carbon in our propane, so let's add a coefficient of 3 to our CO2, and...
Your coefficients multiply everything in the compound. Since you have 4 atoms of molar in the H2O and 6 in your 3 molecules of CO2, that equals 10 of molar. 2 is a factor of 10.
Oh yeah, thanks, oxygen. No coefficient for our propane because there's only 1, and I think we're balanced.
I believe so, Zinc. 3 portions of carbon on the left, 3 on the right. 8 portions of hydrogen on our reactant side, 8 on our product side, and 10 portions of oxygen on each side. It's a balanced chemical equation.
So you see, Yuri, the atoms of your propane didn't vanish. They just combined with oxygen from the air to form new molecules. And some of those molecules, like CO2, are invisible gases always in the air around us.
When I get bored, I get sleepy.
Ruth, the judge said no sleeping. Let's have you get up and try one. The likely problem with Yuri's flowers is that they were unable to properly photosynthesize. Without the right portion of reactants, the products for photosynthesis can't be made, and the law of conservation of mass, any well-balanced chemical equation, explains this.
So in theory, my brother's criminal activity killed his flowers. He's a murderer.
That would be a hypothesis, not a theory. A hypothesis is an educated guess that can only become a theory after it's well tested.
Oui, oui. And a theory, after being confirmed by countless scientists over many decades, becomes a law.
Yes, scientific laws have failed to be disproved. Ruth, time to get balancing.
This is confusing. Doesn't the L mean liter and the S mean second?
When written in parentheses in a chemical equation, they stand for liquid and solid.
So I need to look for common factors. 12, 6, and 2 all share the common factor of 2, right?
Fantastic, Ruth.
I guess we need a coefficient of 6 in front of the CO2 on the reactant side to match the 6 on our product side, and 6 times 2 is 12. So we need a 6 in front of the H2O, and I guess just one C6H12O6, and
That is moi, and my twin again at the end. You must add 6 of us, because there are 18 total of us on the left. 18 minus 6 in the C6H12O6 means you need 12 more of moi, or 6 pairs of oxygen twins.
Ruth, brilliant. But you can erase the 1 in front of C6H12O6 because when there's no coefficient, we presume there's only 1.
you're always a critic, Xenon.
H2O is water, right?
That's right.
And we always have CO2 in the air around us, no matter what.
Correct, Yori.
Now I know how to save my flowers. They don't need propane, they need water.
Mass can't be created nor destroyed. This is a law we cannot avoid. When substance shifts and bonds are made, well, atoms rearrange but never fade. It's the law.
That's right, bro.
Don't break the law. It's the law.
Conservation of mass is a beautiful law.
Don't break the law. Chemical equations, ordinance, reactants and products in balance. Atoms at the start don't go away. They rearrange but they never do stray. Equality, it rules the day. Atoms just don't run away. Atoms we start with, that's where we end. Conserve, it's the law, it would not bend. It's the law.
That is the truth.
Yup. Don't break the law. It's the law. Yeah, man, it's the law. That's the way it is. That's the way it's going to be. Don't break the law.
Don't fight it.
Plasma to liquid, solid to gas. It's the law. Conservation of mass. While matter may morph its shape or hue, universe's mass has constant value. Equality, it rules the day. Atoms just don't run away. Atoms we start with, that's where we end. Conserve, it's the law, it would not bend. It's the law. That's right, man, that's what I'm trying to tell you. Don't break the law. It's the law.
It's impossible to break.
Don't break the law. It's the law.
You better not even think about it.
Don't
won't
break
think
the
about it.
law. It's the law.
I've learned my lesson.
Don't
I
break
think we
the
better get out
law.
of
It's the law.
Okay, Yuri, hand me the sugar.
What's the magic word?
Please. What? Where's the rest?
That's all we have.
Hello, what are you baking, Yuri and Ruthenium?
Oh, hi, Xenon. Our parents are out for the night, and they left us some money for dinner, so we decided to buy cookie ingredients.
I was trying to bake cookies, but my stupid brother here didn't pick up sugar at the store.
Ruth, that's not nice. You don't have to call Yuri names.
Yeah, we all make mistakes.
Okay, fine. My less than optimal intelligence brother here can't follow a simple shopping list.
Ruth, it's not that big a deal. Just cut the recipe proportionally and make a smaller batch of cookies.
Say what?
You just need to use a little stoichiometric math to assure you cut your other ingredients by the same ratio, and then your cookies will be fine. Let me see your recipe. Shortbread cookies. Well, it looks like you have excess amount of butter and flour, which means your limiting reactant is sugar. The recipe calls for 2 sticks of butter, or 227 grams, 250 grams of flour, and 184 grams of glucose sugar. It looks like Yuri only has, I'll guess roughly 90 grams of sugar, or about half of what you need.
So if we just cut the other ingredients in half...
Bingo, Yuri. Smart move.
I think we've already determined he's not smart.
Or we could just make more sugar.
Now you're really sounding LTOI.
What's that?
Less than optimally intelligent. Duh. Now I'm starting to think you're both LTOI.
Ruth. Actually, Yuri, that's a brilliant idea. Let's see if the recipe book includes a chemical formula for sugar. Okay, here we are. It looks like all we need are 6 moles of carbon dioxide, or CO2.
Moles? Ooh, like those things growing on great-grandma's face?
No. In chemical formulas, moles are atomic portions equal to 6.022 times 10 to the 23rd power particles of a substance. Anyhow, we'll mix a ratio of 6 moles or portions of carbon dioxide with 6 moles of water, and that will yield 1 mole of sugar with some oxygen left over.
Yeah, we don't need any oxygen in these cookies.
Well, they do need to bake in the presence of oxygen.
Mom usually keeps some carbon dioxide in here somewhere. It doesn't look like we have any left.
Oh, sure we do. Carbon dioxide is an invisible gas. Okay, this jar contains 176 grams of CO2. So, 176 grams of CO2 times 1 mole of CO2 per 44 grams of CO2 equals 4 moles of CO2. Alrighty, as long as your parents have paid the water bill, we'll have plenty of water, our excess reactant, but only 4 moles of our limiting reactant to CO2, because we need a ratio of 6 moles of CO2 for every 1 mole of glucose sugar. So this means we can only create 4/6 of a mole of sugar. Glucose is about 180 grams per mole. Stoichiometrically, that means 4 moles of CO2 times 1 mole of C6H12O6 per 6 moles of CO2 times 180 grams of C6H12O6 per 1 mole of C6H12O6. Of course, we cross-cancel our units diagonally, and then we multiply across. 4 times 180 equals 720, and we divide that by 6, so that equals 120 grams of C6H12O6 glucose sugar. Presuming Yuri has about 90 grams of sugar on his spoon there, 90 plus 120 equals 210 grams of glucose sugar. But your recipe only calls for 184 grams of sugar, so...
Oh, that's more than enough to make a full batch of cookies.
I was just gonna say that.
No, you weren't, 'cause you're a little LTOI.
Yuri, 2 wrongs don't make a right. Anyhow, Ruth, that's stoichiometry. It's the math that explains ratios and chemical formulas.
And cookie recipes.
Oh, wait, Xenon. How'd you know how many moles and grams and all that?
Well, I have molar masses from the periodic table more or less memorized, but that's a topic for a future video.
Video? What do you mean?
Oh, you two didn't know? Your parents have a nanny cam in that teddy bear over there.
What? My parents record my every move when they're out? Oh, no.
Yeah, Ruth. They know when you've been naughty and saying mean things to your brother.
And Yuri, they know when you've been nice.
Xenon, I can't believe they pinned me against you. You're so smart.
You'll be fine, Yuri. Just concentrate.
Ladies and gentlemen, welcome to What the Heck, the show in which we give answers, you guess the question. I'm your host, Boron.
And I'm your co-host, Silicon.
Before we meet our contestants, Silicon, what kind of drink did you just hand me? Are you trying to poison me with this muddy concoction?
Well, maybe you could pour water onto your own concentrated brown goo drink mix next time. I'm your co-host, not your servant.
Someone hasn't read her contract. Anyhow, all welcome to What the Heck. Look out for possible particles flying from our first contestant today, our very radioactive uranium.
Our next contestant from the noble gases, give it up for Xenon.
And our third contestant from the periodic table's D block, welcome Ruthenium.
Contestants, our first answer. This is a mixture in which a solute is dissolved by a solvent.
Solution.
Ooh, I'm sorry, Xenon. All responses must be phrased as questions. That's a 1,000 electron deduction.
What's a solution? Not acceptable. Remember our show's title. Yuri?
What the heck?
What the heck is?
What the heck is a solution?
That's right, Yuri. You just scored the first 1,000 electrons. Now, I'm not sure if we can call this mud in my cup a solution.
Maybe if you took the time to learn basic solubility rules, Boron, you could make your own cup of brown goo.
I just got lucky that time.
You'll be fine, Yuri. Remember, concentrate.
Next answer. The substance in Boron's mug might be described this way.
Concentrate, concentrate.
That's right, Yuri. It's a concentrated solution. You just scored another 1,000 electrons. Hey, wait a minute. He didn't even ding his bell. And he didn't say, what the heck. Careful, Ruth. No one likes a whiner.
Let's pause here and get to know our contestants. Yuri, you're in the lead. How do you plan to spend your winnings?
I'll be donating them to the Hungry Molecules Foundation.
Aw, that's sweet. What about you, Xenon? How will you spend your winnings, if you win?
I plan to donate my winnings to the Intergalactic Peace Alliance.
That's great. And how about you, Ruth?
Oh, man, my cell phone is at least 6 months old. There's a scratch on the screen, so it's time for a new phone. What the heck?
Oh, sorry, Ruth, but cell phones aren't allowed on set.
And you just said, what the heck, before an answer was given. That's a 1,000 electron deduction, times 2.
Next answer. This is one way we can make the solution of brown goo in my mug less concentrated.
What the heck is Warm it up.
Oh, no. I'm sorry, Xenon. That's not the answer we're looking for.
What the heck is add water?
Judges? Yes, our judges will accept that answer.
I'm sorry, that's not exactly accurate. There are several ways to create a less concentrated, more diluted solution. Certainly, one way is to add water. Sometimes you can add more solvent to your solution to dilute it. This is true, and although your solvent will often be water, it won't always be.
That's great, Xenon, but...
And of course, if your solute won't dissolve in your solvent, you've reached your saturation point, and then often just warming up your solution is all you need to get your solute to dissolve.
Yeah, Xenon, are you questioning the wisdom of our judges?
Well, yes, I guess so. And I wasn't finished. Now, your brown goo is clearly saturated and rather viscous, but were you to vaporize it, resulting in a gaseous solution, then adding pressure to it will change its concentration.
Oh, Xenon, questioning our judges is not allowed.
That's a 5,000 electron deduction, Xenon.
What the?
Ooh, Xenon, you're not going to risk another 1,000 electron deduction, are you?
Our next answer is the daily triple. This is an example of two things that can be mixed together to form a solution.
Well, again, there are many possible questions to this answer, so what the heck? Here goes. You can mix two gases to make a gaseous solution. You can melt two metals together to create an alloy. You can dissolve a solid in a liquid or mix two liquids, and of course...
Whoa, Miss Smarty Pants, we can't follow complicated responses.
A solid dissolved in a liquid.
No, sorry. That's an answer, not a question.
What the heck are two liquids?
That's right.
Next answer. It's equal to moles of solute divided by liters of solvent.
What the heck is molarity?
Ooh, Miss Smarty Pants finally scores! But it doesn't really matter because it's obvious you and ruthenium will never beat Yuri's amazing number of electrons.
Congratulations, Yuri. It looks like the hungry molecules won't have to starve anymore. But not to worry, Xenon and Ruth. You've each just won our consolation prize, an entire year's supply of concentrated brown goo.
Delicious brown goo, concentrated solute. Mix it with the solvent and you'll have a goo day.
Concentrated brown goo powdered solute. Dissolve it with the solvent of your choice to make a delicious solution. Warm it up when saturated to increase solubility of its gooey goodness. Evaporate it when it's too diluted to make your solution the perfect consistency. Ideal molarity is 2.5 m or 2.5 moles per liter. Concentrated brown goo is made in a factory that processes fertilizer, may contain traces of manure.
Thanks for joining us all, and we'll see you soon when once again we all say...
What the heck?
Oh, hi, Xenon.
Go away, Xenon. We can't hang right now.
Looks like you two have quite a mess to clean.
Yep, we've been grounded. Our parents won't let us leave the house until this is cleaned up. Trust me, Xenon, you don't want to be here right now. My sister's in a very bad mood.
Yeah, whatever. I heard that. Just go away, Xenon, before you get us into more trouble.
Maybe I can help. What happened?
It's all Yuri's fault.
No, Ruth started it.
You're the one who said I can't cook.
You're the one who started throwing food at me.
Goodness, you had a food fight? Yuri, what is that you're cleaning?
My sister made blood pudding with pickled Brussels sprouts. Somehow most of the pudding landed on the walls, and most of the pickled Brussels sprouts landed on the counter.
Did she get the recipe from vomitousfoods.org?
Yep, that's the one.
Yuri, are you trying to clean up blood pudding with this? You're not using the right cleaning solution.
Mom said don't use toilet cleaner in the kitchen, so I switched to this stuff.
This cleaner is acidic and blood is a base. Ruth, you're having the same problem. It appears you're trying to clean acidic pickled Brussels sprouts with an alkaline cleaner. You two should try switching your cleaning fluids.
Well, look, that dissolved the blood.
That's lovely. The rule in chemistry is like dissolves like. Acids dissolve acids and bases dissolve bases. You need a cleaner with the right pH to get the job done.
What do you mean?
You might recall that ions are atoms or molecules with an imbalance of protons to electrons. pH is a measurement of hydrogen ion concentration in solutions. An acid donates hydrogen ions and has a pH measurement of less than 7. A base, on the other hand, neutralizes an acid and generates hydroxide ions. These have a pH of above 7 and as high as 14.
Blah, 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 Xenon. Who cares as long as we get this kitchen clean and get out of here?
I'm listening.
Water, of course, is also known as H2O. It generally has a neutral pH of exactly 7, but it can break into both hydrogen ions and hydroxide ions, forming a weak acid or a mild base. That's why water is considered the universal solvent. It can dissolve almost anything.
Let's test your hypothesis.
Ruth!
Why on earth?
Well, you didn't dissolve, Xenon. It just goes to show that Miss Smarty Pants here doesn't always know what she's talking about.
Ruth, that was kinda mean. But it does prove Xenon's not a witch.
Good heavens! Why would you...
Oh yeah, Yuri, like that old movie we saw last week. Sorry, Xenon, I guess I overreacted.
Like when you started throwing food at me.
You had it coming.
Hey, look, Ruth, Xenon was right. Look how shiny the counter is looking now. Thanks, Xenon. I don't care what Ruth says. You're pretty smart.
Thank you, Yuri. And Ruth, apology accepted.
Say, Xenon, in case we ever get into another food fight, how do we know how to figure out whether something's an acid or a base?
This is pH indicator paper. It will change colors as you dip it into any liquid. Why don't you each spray a few drops of cleaning solution on the counter for me?
What are we supposed to do with this?
Distilled water. Perfect. On the count of 3, let's all dip pH paper into our drops of liquid. 1,
2, 3. Whoa, that's some trippy kind of magic, Xenon. Oh, maybe you are a witch.
No, Ruth. We simply match the new color of our pH paper to this chart.
Oh, look! My cleaner is a base.
Yeah, and mine is an acid. And Xenon, you're just nothing.
Neutral, Ruth. Distilled water is pure. No dissolved minerals like tap water, so again it can break down into either a mild base or an acid.
I guess that explains why you can melt a witch with water, but not you, Xenon.
Come again?
You are strong and independent, Xenon. Witches, they must be kinda weak if you can dissolve them in water.
Well, you do realize that movie you watched was just a fairy tale.
Yeah, Yuri, that girl in the movie? Come on, we all know humans are a myth.
Yeah, but talking scarecrows and flying monkeys, I don't know, Ruth, sounds to me like it's based on a true story. Follow the Munchkin rainbow, follow the Munchkin rainbow, follow the Munchkin rainbow.
No, the song goes, Follow the fork in the road. Follow the fork in the road. Follow the fork in the road. Follow the... Stop messing up my song!
Don't forget to like, subscribe, and ring that beautiful bell.
And check out our channel for more links, including free educational resources.
And our social media links.